Thanks for having me. It's great to be here at my first JDK IO, and I'll definitely do my best to not help induce post-lunch food coma. So I'm here today to talk about ServiceMesh with Istio and Eclipse MicroProfile. So how many of you have actually heard of ServiceMeshes or Istio in particular? A few. Any of you actually using ServiceMeshes? Okay. And how many of you have heard of Eclipse MicroProfile? That's about a response. Anyone actually using Eclipse MicroProfile? Okay. So who I am, I'm an engineer at Red Hat. I'm the co-founder and project lead of Thorntail, which was formerly known as WildFly Swarm, and I'll talk more about that a bit later. I'm also the founder and project lead of a new project called SmallRye, which is around Eclipse MicroProfile implementations, which I'll also talk more about later. And I'm heavily involved in the Eclipse MicroProfile standards organization. Well, I shouldn't say standards organization because they're not a standards org, but dealing with defining specifications for microservices and cloud native development. And you can get me on email or Twitter with those details. I'm also currently writing a book on enterprise Java microservices. I actually finished, I think, all the reviews, updates a couple of weeks ago, so it's now off to the production process, and in a few months it should be able to land in a nice hard thump on your desk. So moving on to ServiceMesh. Now, typically with microservices, we have all these other concerns that we need to worry about. So there's discovery, load balancing, resiliency, metrics, and tracing, just to name a few. When you're developing microservices, in the past, we've typically used specific libraries for these tasks. So Netflix provided a lot of libraries that helped with discovery and load balancing, such as Ribbon, and then Hystrix for resiliency and things like that. Now that's all fine and well if you're all using the same language, you can all use the same libraries, but that doesn't really give us a lot of benefit in terms of polyglot nature of the world that we're becoming a part of. So we need something that can work cross-runtime, cross-language, and not have to have our applications modified to work with these things. Because that's one of the things with the Netflix libraries is they work well, but you need to change your code to use them. It just doesn't magically happen for you. So ServiceMesh is a dedicated infrastructure layer for handling microservices and their interactions. So what does that mean? Some of the main capabilities around that are things like traffic management, so being able to route between different versions of the same microservice. Observability, so built-in tracing of everything that's going on in the Istio service mesh. Policy enforcement, so you can do things like restricting which services can call others through the use of service accounts and things like that. And then also adding identity and security. So one of the big ones there is the ability to activate authentication across the entire Istio mesh, and with Istio's case, you can then add mutual TLS between all services. And the big benefit there is it gives you that certificate authentication between services without you having to code anything or upload certificates or anything. It handles all that for you. So obviously the service mesh du jour is Istio, so that's the one we're going to be focusing on. So why is it good? As I mentioned, being able to support polyglot development. So there's no injection of anything specific to handle these operations into your microservice code. And it kind of acts as a thing in the middle to deal with that. So everything that happens between your microservice and anything else. So in some respects, the microservice is shielded from the outside world, and it doesn't really know anything other than communicating with the proxy, even though it doesn't know it actually is communicating with a proxy. So there's other things like intelligent routing and load balancing, as I mentioned, so that it enables you to do things like A/B testing and canary releases and switch the percentage of load between different versions. And if you're finding issues, then you can easily change the configuration and roll back again. In addition, there's circuit breakers giving you things like retries, timeouts, and that's one of the areas that we'll come to with MicroProfile, given that we have fault tolerance in MicroProfile. It provides a lot of those features as well. So it's how does that work together. Then there's metrics and tracing. So diagnosing issues through tracing is a key feature that everyone wants. We want to be able to observe what's going on with our microservices. to know whether they're performing as we expect or whether there's any issues we need to start diagnosing. So what does that mean in terms of the diagram we saw before? So instead of having service discovery, load balancing, fault tolerance and resilience and all those things as separate things we've got to add to our own microservice, they all get bundled into what they call a sidecar container, which is where the proxy lives. So what it means is that any particular deployment in a Kubernetes pod simply needs the language runtime, so in this case JVM, and your actual microservice to sit on top of that. So what it really means is that the sidecar is sitting in, playing the piggy in the middle between your communications into and out of your pod. And that's how it provides all the different injection to perform the tasks it needs. So Istio in particular is split into a data and control plane. So the data plane is deployed as the sidecar into each application pod, and it's the intelligent proxy which is currently deployed as Envoy, and it's the bit that communicates with the control plane to find out what policies need to be administered, what the rules are, what the routing is, and all that kind of information. It holds that itself. Your microservice doesn't need to worry about it. On the control plane, that's where everything is configured to define those policies, and it's then responsible for communicating that out to all the different sidecars that are part of the data plane. And it's also responsible for overall enforcement of the policies in the mesh. So what does that actually look like? Bit of a mess, but there's a lot going on. So kind of in the top half, we have the data plane with all our pods with their Envoy sidecars, who might be using HTTP or gRPC or pretty much anything to communicate with each other. And then those below, in the bottom half, we have the control plane, where you have the Istio pilot, the mixer, and the certificate authority. So it's in the control plane that the certificate authority does all the work for mutual TLS, and it communicates with the sidecars to perform all those functions. So Eclipse MicroProfile. It is an open source Java microservice specification that was founded by a collaboration amongst a large group of companies that have only continued to grow. Most recently, we've seen Lightbend and Microsoft join, which I must admit I never thought I'd see the day that Microsoft would join something like that, but it's interesting nonetheless. So the current set of specifications that are part of MicroProfile 1.3, which was released in December last year, includes all that list up there. So there's some base Java E7 specifications, and then there's the additional specifications from MicroProfiles such as JWT, fault tolerance config, and all the other ones there. So kind of a brief history of MicroProfile and their releases. The first one was September 2016, which was just based on the Java E7 pieces. And then following July last year, we added config into that. And then September last year, we added a new version of config, some fault tolerance, JWT, metrics, and health. And then the 1.3 last December, which added open tracing and open API as well, in addition to adding some updates to the other specifications. And also a REST client last December as well. Now, the next releases are 1.4 and 2.0. They're scheduled to come out on the 20th of June, last time I saw. Basically, the 1.4 is going to be what's currently present in 1.3, but some updates to a few of the specifications there. And then 2.0, which is also going to come out at the same time, so it'll be a dual release, will be the same specifications from MicroProfile as the 1.4 release, but it'll take advantage of the Java EE8 specifications as base. So it'll update things like CDI, JAX-RS, JSON-P, which are already part of MicroProfile as a base foundation. And then we're also going to add JSON-B. So Eclipse MicroProfile and ServiceMesh. What does that actually mean? So we currently have a ServiceMesh working group that meets weekly with MicroProfile. And it's focused on how Eclipse and the Eclipse MicroProfile and ServiceMesh can coexist and what that means. So one of the examples we have to date is disabling everything except a fallback annotation from within your code if you're using a fault tolerance when you're part of an Istio service mesh, just from the perspective of the configuration of retries, timeouts, all that kind of stuff can be handled at a more global level within Istio. So with the feeling there is that we want to be able to overwrite and say, don't use the application retries and timeouts for fault tolerance, but we do want the fallback. Now there is a slight quirk at the moment with Istio in terms of fallback, in that the way it's currently defined, it returns a 503 status code when it can't find a service and essentially fails back. So it's a little bit messy to handle that properly right now. I understand they're looking at ways to add configuration into Istio to be able to define what you want returned when there's a fallback situation. Another example of something we might do there is, in looking at doing the demo for this, the current way to get metrics picked up by the Prometheus that's an add-on for Istio is quite involved to define the configuration for it to actually pick it up. So one of the things we can do there is have some kind of plugin or tool that can iterate over the code and look for application-specific metrics, and then define the necessary Istio configuration for those to be propagated to Prometheus. So we're currently looking at developing a set of microservice examples, and up there you can see there's the repository where all the service mesh work is going on, as well as there's a Getter chat room that we have, where a lot of us discuss things when we're not in the meetings. So we'd love people to come along and help us shape how Istio and Eclipse MicroProfile work together, because there's still a lot of work to do. So Thorntail. So what is Thorntail? As I mentioned, it's formerly known as WildFly Swarm. So some of you may have heard of WildFly Swarm, hopefully. One of the things we realized in the last 6 months is the name WildFly Swarm had a lot of good and bad connotations associated with it, so it was somewhat confusing for the community from the perspective of, we had Swarm in the name, and then you've got things like Docker Swarm, Giant Swarm. It was quite an overloaded term, and it made it even worse when people would just refer to it as Swarm. It became very confusing as to what anyone was actually talking about. In addition, though the existing code base was based on top of WildFly and its modular class path and subsystems, we wanted to move away from that in the future and try and simplify the code base a bit. So we also wanted to kind of take the WildFly name out of the equation so that we could do something like that and it wouldn't be even more confusing. So that's kind of why we went with looking for a new name, and the community helped us out there, and we all ended up voting on Thorntail. So Thorntail is the implementation of Eclipse MicroProfile for Red Hat. So we have all the specifications implemented in Thorntail. One thing we're in the process of doing now is shifting those implementations into the new project I mentioned earlier, SmallRye. The plan there is that we will work with other vendors and the community to come up with I guess you could say a shared implementation for the specifications of MicroProfile. One of the things with MicroProfile is that we didn't want to take the approach of having reference implementations like the Java specification does, but certainly within Red Hat we were looking at ways to how to reuse it, potentially across something like WildFly so that it could incorporate MicroProfile if it desired as well. And we also had some interest from other vendors looking to assist and share with some of the implementation code, but because of the way WildFly Swarm at the time worked, it made that very difficult for them to take that code and implement it in their own containers. So one of the things we're looking to do with SmallRye is to create that kind of shared implementation that we can all use and we can all work towards, and have something that can be used by anyone. So the first version of Thorntail will be 2.0.0 final. Hopefully this week someone from the team is working on that. So you'll notice it's a bit of a departure from the previous naming as well. Like the last WildFly Swarm release was 2018 5.0. We've realized that although it's cool to do a release every month and put that in the name, that it makes it very confusing for people to know what kind of a state it's in. Are we breaking APIs? Are things changing? Can I easily upgrade? It just made it a bit of a mess. So although it was fun for a few years, we're now switching to a more normal versioning scheme. So the existing WildFly Swarm code will come out as a 2.0.0 final release. And we've already started work on a new 4x branch, which is the entirely new architecture we've come up with. So that's where we're not basing on WildFly. We're using just the upstream implementation, so we're picking things like Weld for CDI, Undertow for Servlet, REST Easy for JAX-RS. And we're just picking the pieces we need that WildFly also depended on, but we're kind of cutting out the middleman. And that allows us to have a more flexible architecture, and it's all based around the CDI programming model. So everything's injectable all over the place and within your application as well, simply because we're now also using a flat class path. So it makes it a lot simpler for us to develop, it makes it a lot easier for you to use, and it should be a lot easier for you to bring your own libraries along as well. Okay, so let's actually, get started on some stuff here. So what I'm going to do here is, this is a command, it's currently called Istio OC. It's a fork of the OC command from OpenShift that then bundles in Istio as well. And you can see there I've got some flags for starting Istio and also starting the authentication with Istio, which activates the mutual TLS. And I've also got some password and username there for Kiali, which is an observability project that's being integrated into Istio as well. So we'll just start that up. So at some point, I believe this command will be merged upstream into the current OC command. And as you can see there, we're using OpenShift version 3.9. So while that's going on there, I will just briefly talk through what we have here. So what I've got is just a very simple couple of services. So I have a UI that calls a service to get a greeting, and then this one is what I call a boring name service. So we can see here we're using a MicroProfile config for the injection here. We're defining a config property with a name of default name, and we're saying the default value is John. And then our JAX-RS endpoint just simply returns that name. So it's very basic, nothing too complicated there. On the greeting side of things, it's pretty similar. We're just using the JAX-RS client builder to create a connection to the service. And one of the advantages here is we're just using it as if it's localhost, just the name of the service and the port. We don't need to worry about where it might exist in the OpenShift cluster. The DNS resolution handles that for us. One other thing to point out with the boring name resource is I've got a MicroProfile health check here. So it's just a simple check that returns some data, and then we can define in the template for creating the service on OpenShift. You can see here I've defined the liveness and readiness probe for Kubernetes to point to that endpoint. So it'll curl those endpoints, and when they return a valid response, it'll know that the pod is ready for use, and it'll be available for connections. So let's head back over here. So now I'm just going to log into the system account so that we can have a look at what's been going on. So I'm just going to, we can see all the different projects that have been installed there. The main one that we're interested in is the Istio system one. So we can see these are all the pods that are currently running in there. So the Istio's OC command has given us a Grafana instance, all the Istio pieces like the ingress, the sidecar, the pilot. It also adds Jaeger and the Kiali and then Prometheus as well. So it's quite a lot running in the tin there, but it's certainly advantageous. So what we can do now is see the different routes that gives us. So these are all the URLs that can access those pieces of Istio that have been deployed. So there's like the Grafana, Jaeger, Kiali, Prometheus, and then the Istio Ingress. Now, I should point out that the version of this command I'm using has actually deployed Istio 0.8, which only came out last week. So there are some rough edges with this, shall we say, because they're currently going through a change where previous configuration definitions or CRDs from Kubernetes terminology were deprecated in favor of new ones. Now, in 0.8, those deprecated ones are still meant to work, though I've found that they don't always work. Now, they are looking to be removed for the 1.0 release, which I think is currently planned for sometime in July. But there's some work that needs to be done to figure out what's going on and how to actually make them work. So now if we head over to here, and I'm just going to log into the OpenShift console so we can see things from that perspective. So right now, there's just the initial project in the OpenShift console with nothing there. So if I come over here, I can do I've already packaged the application, and we can build it and then tell it to push a Docker build into the Docker registry that OpenShift is using. And we'll do the same with this one. And this is using the Fabricate Maven plugin to generate that Docker image and then push it into OpenShift for us. So we can see the first one's already nearly finished, and we can have a look at them by having a look at the images over here. And we can see now there's a latest tag for that one. And when this one finishes, we should get updated with another tag there. Yep, so they're all there and happy. So now there's still nothing actually running in terms of a service. All I've done so far is just push the build into there and provide an image. So what I can do now is create the OpenShift pieces we need from the YAML that I showed you briefly. So there's a whole bunch of configuration in there. And you can see as soon as I pushed that, it started to create the service for me, and it's doing a rolling deployment based on that Docker image. If we do the same with this one, so we can now see that we've got the two services coming up, and their rolling deployment status will change as soon as the health check passes. And you can see there the bottom one is already shifted to being active and available. One thing to show there is, close some of this down. The greeting OpenShift template I've used, this is using the previous version of Ingress. So basically it just defines a gateway through Ingress that points to the greeting service we have. This was my attempt at getting it to work with the version 0.8 CRDs, and without success, and it's a lot more complicated than it was before. So I still need to figure out whether I've done something wrong in my configuration or whether there's something wrong with Istio that's stopping this from working as it stands. But it is what it is, it happens. So now that's active, and we can have a look at the pods to see that we can see we've actually got two containers running. We've got the, in this case, WildFly Swarm, because I'm using the 2018.5.0 code. We've got the WildFly Swarm container, which is our actual application, and then we've also got the Istio proxy container, which is the sidecar. So that has happened because inside our YAML template, we simply said that we wanted to inject the sidecar. If I'd set that to false, it wouldn't inject the sidecar. So what we can do is, I think that's going to be in here. So if we go here and edit the YAML, oh, there it is. So if I change that back to false, it'll now do another rolling deployment and turn off the sidecar injection into the pod. So once that's completed, I'll be able to show you the kind of difference that means, particularly with mutual TLS enabled. So before, it was part of the sidecar was injected, which meant there was part of the mesh and mutual TLS was applied between all the services. Right now, the boring service is not part of the mesh, so I can create a route to that service, and I can, oh, it's not on the route, it's that. So you can see there it's giving me the name of John, which is the default value from MicroProfile config. So I can access that route that I've just created on this service. However, if I now go back and edit the YAML, oops, where is it? There, to make it true again, we're now putting the service back into the Istio mesh, and because we have mutual TLS enabled, although this route we had pointed to that service, as far as the mesh is concerned, that route is an OpenShift route, it's not an Istio route. So we won't see that service with that route because the service inside the mesh is essentially hidden from anything else in the OpenShift cluster. So actually I don't need to do that. So if I refresh that, it's like there's nothing even there. If I didn't have mutual TLS enabled, that route would still work even though the service is part of the mesh. But as soon as you enable mutual TLS, the services are literally hidden from anything else in the same namespace. So if we now go back over to here and grab the Istio ingress route, we can see here that just the basic application that I have, which is just a simple UI that calls the API of the greeting service. And this web page is being served from the greeting service as well. So if I invoke that, it comes back and it gives me a value of hello John, and it works again. So what we can do now is show the MicroProfile config. So we can add a value into the environment here. And so I get this right, default underscore name, okay. We can just simply add a value in here and save that, and it'll redeploy with the change. And then we'll be setting the default value of that, or not the default value, we'll be providing a value for the MicroProfile config to a different name so that when it's active, which should be done any second, we can see that, okay, I think that should work. Yeah, so we're now getting the different name just from setting some configuration and having that service redeploy. Okay, so what we can also do is, we've made some calls there, so we can have a look at what things look like in, where is it, Jaeger. So at the moment, I haven't done anything in terms of Jaeger integration or anything like that. So if we, oh, it needs to be HTTPS. So if we go to the Jaeger UI that's packaged, we can see that we have the greeting service and we have our name service already showing up in here even though we've done absolutely nothing. And what you can see with these is that it gives you the route that have been taking. So you can see that it's calling the name service and it's basically saying that it hit the proxy on each of those situations. And it can tell you, shows you like the Istio policy checks that have been triggered. So it gives you a nice thread through everything that's going on. But one issue we have here is that the Istio ingress, where we first came in, it kind of dies when it calls the greeting service, because it doesn't know that things have propagated down. So what we need to do is provide a way for it to propagate that information. So we can do that by modifying our greeting resource. So first thing we need to do is add a dependency to, not that one, was it? No, I think it is that one. Yeah. So we add a dependency on the Jaeger fraction from Swarm, and that'll give us the ability to interact with Jaeger. And then it's simply a case of adding some client tracing. Oops. Into the client that we use to make the call, and then we just need to set the property, what is it set to? Tracing. This will basically pass the span that's been created externally down into the call to the name service. So we can easily get that included by just rebuilding the application quickly and then pushing that build into another container image, an updated image inside OpenShift, and then it will redo the deployment for us with that new version. While that's going on, we can have a look at Kiali, which is a slightly different view of things. So this is just the passwords that I provided when I started with the Istio command before. And this gives us a interesting view of the calls we've made. So you can see there that we've come from an unknown location as far as it's concerned. We went into Istio ingress and we called the greeting service, and we called the boring service, but it's part of a wider name service. It's just at the moment there's only one version. And so this gives us a nice way to trace all the calls between our different services without having to actually know what's calling what. Obviously this is fairly simplified because we're only dealing with 2 services, but if you had half a dozen to a dozen or more, this would give you a really good picture of what's going on. Let's see, so that's done, and we should find that that's redone. So we'll just refresh that. So if we now invoke, oh, why is that giving 500? Okay, I'm not sure why that's happened. That was working not that long ago. Okay, so we'll take that out because we need it working for the next bit. One other thing I'll do here is I also have what is called a cute name service, which does a slightly different name. It has a generator that combines some different words together to give a slightly different name. So let's build that one up and deploy that, and it will get deployed as a different version of the same name service that we already have for boring. So build that one on OpenShift. So as I mentioned, the metrics is something that MicroProfile provides. It has a lot of base metrics out of the box, and then you can add your own. At the moment, there's not a great way to integrate that with Prometheus without having to do a lot of manual configuration. So that's something that we're going to look at in MicroProfile, I'm sure. It's certainly something I'll be requesting because I don't want to have to write that every time it's needed. What else? So fault tolerance is a tricky one. I had it working with Istio 07 and then it stopped working with 08. So it's another one of these, I'm trying to be too clever for my own good by using the latest of something. So I need to go back and have a look at that. But the general idea with the fault tolerance particularly is that You can still have your application deployed with all your retries, your timeouts, anything like that, and we can just set a single environment property to basically disable all those except the fallback. I think at the moment the fallback probably won't work with Istio just because it returns a 503 as opposed to some kind of exception that the fallback can capture. So we need to do some work on that to get that integrating properly. Okay. And the last thing I need to do here is to create the actual Qt name service in OpenShift. So when that's ready, there we go. So it's popping up. So you can see there that under the name service, it's a single application, but we've got different versions being deployed. So that'll just take a second to come up, and then we'll be able to see other things in action. Okay, so that's now up. So let's clear that, and if we invoke that, so that's our regular boring service, and now we can start seeing responses from the other one. So typically when you've got multiple versions of the same service name as far as Kubernetes is concerned, it will automatically load balance at around 50-50. Now it might take some time to reach that kind of level, but that's what it's aiming for. You can see there we're now pretty much at a 50-50 level as we keep going. And what we can do is have a look at reload Kiali over here. So you can now see it's showing that we've actually got two different kinds of name service instances there, the boring and the Qt. There's also a view of services here that allows you to see specific details around its health and its error rate. So you can see there we've got a slight error rate with the greeting service of 1.29% from when we had the problems calling the name service. So this gives you an overall view of the health of those services as well. And if we go back to the Jaeger UI and maybe that didn't refresh. Okay, here we Okay, not sure why that's not tracing to the Qt name. So needless to say, Istio 08 has some issues that need to be sorted out, and some issues I need to investigate when I get back home tomorrow night. So what else can I show you? So I've kind of shown you all those pieces. Now in terms of, with the two services with the different versions, what I would normally have shown in the past is something like this. The top piece is something that was working in 07 and should still work in 08, but isn't because it's the deprecated format. So with something like that, you can say that I want to weight the calls to the Qt name service to 90% of traffic and boring to 10%. You can do it using simple weighting. You can do it with request headers. There's many different ways you can do the splitting between different versions of the same service. So that's where it's beneficial for A/B testing, canary deployments, and that kind of thing. The new format is somewhat similar but different. They're now moving to a concept of virtual service, which for me is somewhat reminiscent of Apache web server configurations. So it's a similar idea in providing weight and routing to the different services. In terms of circuit breaker, once again, this is something that was working in Istio 07. We would define a circuit breaker up there for the name service, and we would say that like there was max connections of 1, so we could show it failing over and restarting instances and things like that, but that didn't work the way I was expecting it to. So another one of these add to my list of things to look at. This is the new format with the new CRDs for Istio 08 and beyond. So it's a little different. There's not really a concept of a circuit breaker configuration. It's more a case of a policy around the traffic and what needs to happen. There are also some differences in the circuit breaking within Istio, given that Istio's a lot more forgiving than Hystrix, for example, in terms of circuit breaking. With Hystrix, it's very much a case of if you trip the circuit, it's open. And then you've got to wait for the timeout before you can start doing a half open state and trying to initiate new requests. And if they work, well, then it goes back to open, closed, and everything works fine. With Istio, it's very difficult to trigger the circuit breaker. We had some examples we were doing at Red Hat for some work, and we had to create a UI that could simulate like 20 or 30 concurrent requests repeatedly from the UI to get anywhere near close to triggering the circuit breaker in Istio. And that was with setting the connection, max connection to one HTTP connection. Istio is very good at not falling over when you think it should. We thought that with one HTTP connection and sending 20 at it at once, it would fail over immediately, and it's not the case. It seems to handle itself pretty well, which in some ways is really good, but when you're trying to demonstrate it, it makes it very hard to make it break. So that's kind of where we're at with that situation. Let me think. I think they are the main points of what I wanted to bring, so I guess that means we're heading over to here and saying thank you very much for listening to me yabbering on. There's a bunch of links up here to the Thorntail project, our Thorntail website, the Thorntail forums. We're also on, yeah, we've changed. We're now on IRC for Thorntail instead of WildFly Swarm. We're based, the team is based in Europe and the US, so there's usually at least one of us online and around to answer questions in the chat room. There's some links there to the Eclipse MicroProfile project and site, and then there's a link to the SmallRye site, although there's absolutely nothing there yet, and a link to the SmallRye groups, and once again, my contact details. So thank you very much, and if there's any questions, fire away. Kiali was started. Okay. So for Kiali, in this instance, it was part of the Istio OC command, because I'm passing the Kiali username and password into the startup. So basically, the Istio OC command it uses Ansible to create a whole bunch of services in OpenShift, and we could see all these things it created. So it creates all those pods for you and services. It sets them all up, links them together so they're all integrated into Istio. It's by far the easiest way to get started with Istio that I've experienced compared to trying to install Istio into an existing Kubernetes or OpenShift instance. And that's actually a good point. I think, where is it? Yeah. So at the moment, all that code is in a fork of the OpenShift OC command. So it's OpenShift-istio/origin, and that's the latest command was added 4 days ago that adds Kiali into the startup sequence. So it bundles Prometheus, Jaeger, Grafana, and now Kiali, as well as Istio, and wires them all up together to communicate and authenticates them all, and it's pretty nifty. Any other questions?
Do you have any intelligent routing based on user or HTTP?
Yes, so Istio is extremely powerful in terms of that. Let me see, I think this is the new version. So, so you can do URL rewriting, you can do matching on different prefixes. Let's see if there's any other examples. You can also use HTTP header content. I'm just trying to find if there's an example of that. This is an example of the new destination waiting to move between different versions of the same service. And there's a gateway set up. I wonder if it's in there. Okay, can't seem to find one right now, but you can use parts of request headers. You can even add your own special headers into the request and then use those as part of the matching or checking and redirect to different versions of the same service based on those parameters. The MicroProfile REST client essentially wraps the JAX-RS one, but it enables you to define it as an interface. So you can create an interface that looks like a JAX-RS resource class in terms of it's got @path, it's got the gets, the puts, and it has all the information that you would have on the server side. It's just defined on an interface. And then you can basically create a proxy to that interface and then execute the client calls. So I think it's something that's been part of REST Easy for quite a while. I think it's popular enough that at some point we'd probably want to try and get it into the JAX-RS spec. I've heard that that's been tried in the past, but there was disagreement about it. But I think it's something that would certainly be beneficial. Yes, you had a question?
Yes. Do you have any idea of the release date?
For which? Well, Istio itself, I believe 1.0 is going to come out in July sometime. In terms of the tool I've been using, which is developed by a team at Red Hat, I know they're looking, I believe, to go into some kind of tech preview once Istio is 1.0, so probably July, August, they'll have a tech preview available for you to play with, and then they're probably going to go GA anytime 6 to 12 months after that, depending on what kind of issues are found or things they decide they want to add. But it will be coming soon, and I think it will be planned to be integrated into the actual or, OpenShift Origin OC client at some point as well. Given how much things have changed between versions of late, it's kind of hard to say. I'm hoping the new CRDs they've released, so all this, the new networking Istio v1 Alpha 3 stuff that came out in 0.8, that they're now happy with how that looks and that it's going to stick around for 1.0. So I think it will probably be reasonably stable so long as they don't keep changing their minds about what they want in it. Any other questions?
This is really an amazing piece of software. Fantastic. One more question.
Yes.
This terminology of sidecar. Can you explain a little bit when it's a sidecar and when it's not a sidecar?
So sidecars, I'm trying to think that it did originate before Istio existed, the concept of having a sidecar in a Kubernetes pod, but I can't remember where it came from off the top of my head. But essentially all it means is that a Kubernetes pod can have many containers running. So you could, in theory, deploy different applications to different pods within the same container. Now, obviously, that's not something you want to do because then you get into all sorts of issues of if one pod goes haywire, then it could bring all the others down and you've got to restart the container. So that's why we tend to have one application on one pod on one container and just keep it as small as possible. But with this kind of technology, the sidecar idea is that you're deploying something into the same container. It's on a different pod, but it's in the container and therefore has access to things that it wouldn't have access to if it was outside the container. So there's a lot of things around security that you can do because you're in the one container, as opposed to being outside and then you've got to open things up to be able to do that from the outside. So it's really about keeping everything as tightly knit as it can be, and only really communicating out as necessary to get the rules from the control plane and provide information to Prometheus and things like that.